What's up, quantum explorers? Welcome back to MetaVerse Update, where we bring you the absolute cutting edge of tomorrow today. First up, get this. Quantum Motion has just dropped the industry's first full-stack silicon CMOS quantum computer, built using the same tech as your everyday gadgets. Next, the big leagues are getting involved. Google Quantum AI has been selected by DARPA for their crucial quantum benchmarking initiative, aiming to figure out if utility-scale quantum computers are really on the horizon. And speaking of massive moves, IonQ is making waves by acquiring Oxford Ionics in a staggering $1.075 billion deal that could supercharge the race for scalable quantum systems. Finally, we're diving into the potential seismic shifts on the horizon as quantum breakthroughs could seriously threaten Bitcoin's security by the 2030s. Stick around for all the details and make sure you're subscribed and have that notification bell on. Quantum Motion shatters the mold with first full-stack silicon CMOS quantum computer. This is huge. Quantum Motion has officially unveiled the industry's very first full-stack quantum computer. And get this, it's built using standard silicon CMOS fabrication, the same revolutionary tech found in all our conventional computers. Deployed at the UK National Quantum Computing Centre, this isn't just another prototype. It's the first full-stack quantum machine to leverage mass-producible 300 silicon CMOS wafer technology and the inaugural silicon spin qubit system to be installed under the NQCC's Quantum Computing Testbed program. This breakthrough promises to accelerate the development and accessibility of quantum computing by utilizing established manufacturing processes. This monumental achievement has the tech world buzzing, with analysts predicting a faster path to widespread quantum adoption and commercial viability. The implications for industries from medicine to materials science are staggering, as the barrier to entry for powerful quantum computation is potentially lowered significantly. But hold on, the quantum race is far from over, and our next story reveals who's stepping up to the challenge in a major way with DARPA. Google Quantum AI joins DARPA's Elite Quantum Benchmarking Initiative. Get ready, because Google Quantum AI is now officially on the front line of quantum validation. They've been selected by the U.S. Defense Advanced Research Projects Agency, DARPA, to participate in the groundbreaking Quantum Benchmarking Initiative, or QBI. This isn't just about playing. It's about setting the stage to rigorously assess quantum computing approaches and determine if utility-scale, fault-tolerant quantum computers are achievable by the ambitious target of 2033. Being chosen means Google will collaborate directly with DARPA's technical experts, who will serve as independent validators for their cutting-edge quantum computing roadmap, providing critical, third-party benchmarking that the entire quantum industry desperately needs. The QBI isn't just a single-player game. It's designed to pit various quantum technologies against each other. Think superconducting qubits, photonic systems, trapped ions, and more, all under a shared set of metrics. This underscores Google's relentless mission to build the quantum infrastructure that can tackle humanity's most complex challenges, from designing life-saving medicines and pioneering new energy solutions to optimizing intricate machine learning algorithms. And that's not the only major power player making moves. We've got a massive acquisition that could redefine the quantum landscape next. IonQ acquires Oxford Ionics for $1.075 billion in quantum power play. This is massive news shaking up the quantum world. IonQ, a leader in quantum computing, has announced a monumental deal to acquire the UK-based Oxford Ionics for a staggering $1.075 billion. This strategic acquisition is set to dramatically accelerate IonQ's journey toward delivering scalable and fault-tolerant quantum computers. By merging IonQ's robust quantum compute and networking stack with Oxford Ionics' cutting-edge, high-fidelity trapped ion-on-a-chip technology, the combined entity is poised to push the boundaries of what's possible. For us, this deal signifies a huge boost for the UK's quantum research and development prowess, and signals an accelerated timeline for the quantum systems that could revolutionize everything from pharmaceuticals and aerospace to finance and materials science. The agreement, comprising $1.065 billion in IonQ stock and approximately $10 million in cash, aims to create quantum systems with unprecedented scale and accuracy. Oxford Ionics holds world records in quantum fidelity, a critical measure for reliable quantum operations, while IonQ excels in its application and networking stack for trapped ions. Together, they aim for 256 physical qubits with 99.99% accuracy by 2026, scaling to an astounding 10,000 qubits by 2027 and further targets of 2 million qubits by 2030. IonQ's CEO Niccolo de Masi stated, IonQ's vision has always been to drive real-world impact in every era and year of quantum computing's growth. Today's announcement of our intention to acquire Oxford Ionics accelerates our mission to full fault-tolerant quantum computers with 2 million physical qubits and 80,000 logical qubits by 2030. The tech community is electric with this news, seeing it as a pivotal moment that solidifies IonQ's leadership and accelerates the global quantum race. Analysts are already projecting massive economic value from quantum technologies, and this merger positions the new entity to capture a significant slice of that future market. But while some are building the future, others are eyeing its potential vulnerabilities. Our final story looks at a looming quantum threat that could impact a digital titan. Quantum computing's looming threat to Bitcoin's security by the 2030s. Could quantum computers spell the end for Bitcoin as we know it? Experts are raising alarms that the rapid advancements in quantum computing could pose a critical threat to the long-term security of Bitcoin by the 2030s unless robust defenses are implemented. The core issue lies in quantum machines' potential to break the very cryptography that secures digital assets. Specifically, Shor's algorithm, when run on a sufficiently powerful quantum computer, could theoretically crack the encryption protecting Bitcoin private keys in mere hours, leaving vast sums vulnerable. While current probability models suggest a low chance of Bitcoin being compromised before 2030, the risk escalates dramatically, with estimates showing a 45–60% chance of breaches between 2035 and 2039, and near certainty by 2050. Sudden leaps in large-scale, fault-tolerant qubit development or even government mandates could drastically shorten this timeline. To preempt this existential threat, experts are urging a proactive shift towards post-quantum or hybrid cryptographic solutions, with critical migrations needing to be completed by the mid-2030s to safeguard the Bitcoin network. The financial and tech communities are abuzz with discussions on quantum-resistant cryptography, with developers actively exploring solutions. This potential vulnerability highlights the urgent need for proactive security measures in the digital asset space as quantum technology matures. And that's a wrap on today's Quantum Deep Dive. But don't go anywhere, we've got a lightning round recap and a full call to action coming right up. Wow, what a quantum-packed episode. We saw Quantum Motion deliver the first full-stack silicon CMOS quantum computer, Google Quantum AI get tapped for DARPA's quantum benchmarking, IonQ make a massive $1.075 billion acquisition of Oxford Ionics, and we explored the potential quantum threat to Bitcoin by the 2030s. You don't want to miss what's next in the quantum revolution, so make sure you're subscribed, hit that notification bell, drop a comment below telling us what you think, and follow us on all our socials.